The second video for 4.5 is continuing with our graphs of our sine and cosine functions, but now we're going to do some shifts. So when you have a constant added or subtracted to the cosine or sine function, so like this -4 here, it's going to, just like in previous chapters and normal functions, it shifts the graph up or down, so vertically. So since I've subtracted 4, it'll shift it down 4. Whenever you have something like that happening, the first thing you want to do is change your midline. So normally the graph goes straight through at the x-axis. This is a sine graph, so it would start in the middle, go up, go down, and come back to the middle. Now this midline has been shifted down 4. So instead of being at 0, it's at -4. So I do need to change the scale a little bit. So I'm going to count by 1 for each hash mark there, so that takes me all the way to +8 and -8. So first thing I want to do is draw this midline here. Make sure you continue in both directions. From there, I'm going to do just like I did on previous graphs. I'm going to find my amplitude and my period. So if you remember, your amplitude is basically whatever number's in front of your sine or cosine function. So in this case, it's 2. Before I go any further, I'm going to go ahead and draw those lines. I'm going to do them a little bit lighter, but that means from my midline, I'm going to go, my highest point is 2 above that, and my lowest point is 2 below that. My period, there's nothing happening inside this sine function right there with that theta, so it maintains the 2 pi. So again, I know my basic sine function looks like an S. I'm going to start at my midline. I'm going to end at 2 pi and at my midline. Right in the middle of those, so at pi, I'm still at my midline. Right in the middle of those, I'm going to be at my maximum. Middle of my last two, I'm going to be at my minimum. So this is my first period for my graph. I could continue that backwards, and you should continue that backwards to get a nice complete graph. Oops. Lower that part there, I don't have an eraser. Notice though, I'm always going to start with that first period. A lot of the times if you're looking at an answer or anything, I've made that darker so that really stands out where you're starting. With this next one, it is a cosine graph. First thing I want to look at is this +3 at the end, so it shifted the whole graph up 3. So again, I need to change my scale a little bit. Since I only have to go up 3, I'm just going to count every other one is 1. So 1, 2, 3, 4, -1, -2, -3, and -4. If you remember, normally you have your midline here. Cosine starts and ends at the top. In the middle it's at the bottom. In the middle of those it's between those. So that it kind of makes like this sideways C. So first thing I need to do is graph my new midline. Here at 3. My amplitude, again, is whatever number's in front of my sine or cosine function, so in this case is 1. So that means my highest point is going to be 1 above the midline, and my lowest point is going to be 1 below the midline. Make sure it's not just one hash mark, but whatever you counted by. So we counted so that every other hash mark was 1, so I had to go to every other one there. Then I'm going to my period, which remember is affected by anything that's in front of or multiplied to that theta. In this case it's a 2 there, so normally it'd be 2 pi. I divide by whatever that number was, so again 2. That gives me pi. So my period is pi, which means I'm going to have this full little sideways C going between 0 and pi. So for cosine, remember you start at the top, you end at the top. This time when I end though, it's at pi, not at 2 pi. In the middle of those, I'm at the bottom. In the middle of those, I'm in the middle. So I have this very, very rough first graph. But then I could continue my graph and should continue my graph. Both forward and backward. I know I've said it before, but I'm on a very unstable tablet. You are on paper and should be on graph paper. So yours should be a little bit more stable than my line, but you can see what my curve looks like in general. That's shifting everything vertically, so up or down. Now we're going to look at doing our horizontal shifts. So when that happens, just like if you were shifting like the square root of x minus 2, that shifts it to the right. So whatever's inside that function is shifting it left or right. Whereas if you had the square root of x minus 2, that's outside the function, so that was the vertical ones like we just did. So I have something added or subtracted inside my sine function. To figure out what exactly that's doing, I'm actually going to think of this as my starting point and my ending point. So normally when we do sine, we start over at 0, we end at 2 pi. Cosine, same thing, because that's my normal period. So since normally I would start at 0, I'm going to take what's inside my sine function, so theta plus pi, and set it equal to 0. Since normally I would end at 2 pi, I'm going to take what's inside my sine function and equal it to 2 pi. And then I'm just going to solve each of those. So I would subtract pi, theta equals negative pi. So I'm actually going to start back here at negative pi. Then I subtract my pi, theta equals pi. So I'm going to actually end right here at positive pi. So that's where my first graph is actually going to go, and should be able to see the entire thing, at least one period, sorry, between those two. I still need to answer the question of my amplitude. So again, that's the number in front right there, which would be 1. My period, I'm still looking inside my sine function. There's nothing being multiplied to my theta. So my period is still just 2 pi. And if you look at this, from negative pi to positive pi, that distance is 2 pi. 1 pi, 2 pi. So I have my midline, sine, starts and ends in the middle of those, goes up and goes back down. Not shifted up or down any, so I'm going to start and end at that midline. In the middle of those, I'm at the midline. In the middle of those, I'm maximum, which since my amplitude was 1, I'm just up at 1. And towards the end, my middle, I go to my minimum. So in this case, negative 1. So I have, there's my nice first period. From there, I can continue that and get the rest of my complete graph. So at the end over here, I would then be going up and then back down. At the beginning, in the middle, I would have come down and then back up to that middle spot. So there's my complete graph. Again, you can kind of see my light blue arrows here pointing out what the original starting and ending points were for my first period, and I have that in that darker green to help that stand out. Okay, let's do one with cosine. Again, there's something happening inside that cosine function, adding or subtracting, so that is going to shift it left or right. My normal period for cosine starts at 0. So I need to take whatever's inside and set that equal to 0. My normal period would end at 2 pi. So I need to take whatever's inside that cosine function and set it equal to 2 pi. And then I'm solving this. So I'm trying to solve for theta, so I'd subtract my pi over 2. So I have negative pi over 2. I would divide both sides by 2. Negative pi over 2 divided by 2 is negative pi over 4. So that would be right here for my starting point. Subtracting my pi over 2 over. Oops. Okay, so subtracting pi over 2, subtracting pi over 2. 2 pi minus half pi is 1.5, or 3 pi over 2. Then I would divide by 2, so I have 3 pi over 4. So I'm going to fit my entire first period between those two spots. Make sure you always look at your amplitude and your period. Amplitude, again, comes from whatever number is in front of that sine or cosine function. So in this case, that's just 1. Period, you're looking at whatever number is being multiplied to the theta. So period would normally be 2 pi, but I have to divide it by 2, so I'm getting just pi. If I look at my starting and my ending points, from a negative 1/4 pi to a positive 3/4, or negative quarter to positive 3/4, that distance is just 1 pi. So that makes sense. Switch back to green to get my first graph, my first period. Don't forget cosine starts and ends at the top, goes down in the middle, make that sideways C. So I'm going to start at my maximum. I'm going to end at my maximum. In the middle of those, so be careful, don't just go to your y-axis. But in the middle of negative 1/4 pi and positive 3/4 pi would just be 1/4. Or if you need to count, 2 spaces over, 2 spaces over. But I'll be at the bottom, my minimum. And in the middle of each of those maximums and minimums, you should be at your midline. So very wonky, but there's my first period. Then I could continue that down all the way to the bottom, back up to the middle. Notice that it is still spaced out the same. Even with this very rough graph, you can tell the consistent flow throughout the entire graph. To summarize, when you're graphing your sine and cosine functions, first thing you always need to do is decide if there's a vertical translation, because that will take that midline and either shift it up or down, and you need to draw that first. Then you need to draw your figure out your amplitude. So once you have your midline, whatever your amplitude is, you can put that maximum minimum line in there as well. So I normally make those a little bit lighter, but I still want to know how high and low I'm going to need to go. I'm going to determine my period. So typically it's 2 pi, but if I have like sine, cosine, whatever, of some number times theta, then I'm going to be doing 2 pi divided by whatever that number was to find out my new period. And I need to determine my horizontal shift and translate or shift the graph accordingly. So remember, that's normally it starts at 0 and it ends at 2 pi, so you're taking whatever's in your parentheses. So if it's sine of something with either a plus or a minus, you're taking all of that and setting it equal to 0 and to 2 pi and solving that to determine where you should start and end your graph. With these directions, you can graph things that have both a vertical and a horizontal translation.